Looking at our hypothalamus and pituitary gland, hormones secreted here are the most important regulators of our endocrine system. And this should feel like review. Remember, we have our hypothalamus pituitary axis that includes negative feedback, where our hypothalamic neuroendocrine neurons release hormones that then act on the pituitary gland, which release tropic hormones, which act on the peripheral endocrine glands, that release hormones that exert negative feedback above and target organs and have their physiologic effects below. Our hypothalamic hormones are secreted from neurons in the hypothalamus. They act on the pituitary gland, and they are really an integration point between our two regulatory systems, our hormonal or endocrine system and our nervous system. Hormones that are released from the hypothalamus that act on the anterior pituitary are called releasing factors, and they move from the hypothalamus to the anterior pituitary via a closed circuit circulation system called the hypophyseal portal system, or the hypophyseal portal system. These are vasculature channels, so arteries and veins that connect the hypothalamus to the pituitary. They are not communicating elsewhere. It's a closed circuit system, essentially. The hormones that are involved, I listed them here for you with your definitions, just as a nice reminder and a good study tool, along with the cells that are stimulated and then the cellular response. So, for instance, CRH or corticotropin releasing hormone is released or stimulates our corticotropic cells of the pituitary and then leads to the release of our adrenocorticotropic hormone. The inhibitory hormones involved are somatostatin and dopamine. Somatostatin inhibits both growth hormone and thyroid stimulating hormone, while dopamine inhibits the release of prolactin. And when we go these were the stimulatory. When we go to then the posterior pituitary, there are no hypothalamic hormones that are released into the circulation to then stimulate the posterior pituitary. Instead, there are axons that are located in the hypothalamus that then directly connect via their axonal components and synapse in the posterior pituitary here. So we can see these axons release these hormones, and then they connect and they synapse in the posterior pituitary. The hormones are synthesized within these neuronal cell bodies within the hypothalamus. They're then transported or walked down these neuronal axons where they're stored in vesicles at the axonal synapse. When the axon is stimulated, when there's an action potential that stimulates a signal, these hormones are then released at the synaptic cleft in the posterior pituitary to then systemic circulation. When we look at our pituitary hormones, they're secreted from both the anterior and posterior lobes, and their job is to stimulate secretion of hormones from other endocrine organs. They're regulated by the hypothalamus as well as negative feedback from our peripheral endocrine hormones. Our anterior pituitary hormones are listed here, including the cells and the percentage of how many cells are taking up the anterior pituitary. For instance, growth hormone secreted from somatotropic cells, which is 50% of the anterior pituitary cells in total. The regulation is listed here with a plus sign, meaning it stimulates, and a minus sign, meaning it inhibits. And then the action of said hormone is stated here in this end kind of portion of the table. These, again, are really helpful for studying for your board exams and also learning how, if a hormone is affected, what potential symptoms you might see or what potential pathophysiologic actions you could see in that condition. Our posterior pituitary hormones are just two. Remember, they're secreted and they're created in the hypothalamus and they're stored in their vesicles in the axon terminal until they're released, and that's oxytocin and antidiuretic hormone. Oxytocin is created in the nuclei or the neuron cell bodies that are located in the paraventricular nuclei of the hypothalamus, versus antidiuretic hormone comes from the supraoptic nuclei, or again, nuclei is cluster of neuron cell bodies. So these are just neurons of the hypothalamus. And then we have our actions, essentially, of what they do. One other exciting but kind of random gland that I know you've learned about this week is the pineal gland. And the pineal gland secretes melatonin that helps to regulate sleep cycles. We'll stop here. When we come back, we'll look at our thyroid hormones.